Hey guys, welcome back to our programmer fella, and we are on lead code weekly challenges problem. So today's we'll be discussing problem number 653. It's a two sum. Fourth problem input is a BST. So they will be giving one binary tree, and we have to, and they will be giving one target values, and we have to find out for any two nodes, after adding any two nodes, if it is equivalent to the target values which they have given it. So we have to return true, otherwise we have to return false if we didn't find any value matches with the target. Okay, so for this problem we'll be using hash set approach. Okay, and guys, like, if you have not subscribed my channel, please subscribe programmer fella. Okay, so what problem it says, right? We have to find out the target values by adding two node values. So if you see the problem or example right in below, so right, so we have to pick any two values by adding two values. If we found target number, right, so simply we have to return true, otherwise we have to return false. So in this problem, right, so if you see, first I took 5. If I add with 3, right, it's add, but the target values is what they are expecting 9, so it's not matches. So it will move to the next one. 5 plus 2, it's a 7, again it's not matches. Then it will jump into this values. 5 plus 4, it's a 9. So the kth values, we got the kth values, and simply we return true because we have the values. If we add two node values, we will get 9, and the value is 5 and 2, 5 and 4. Okay, so how we will be achieving in the program? So by using hash set we will achieve these values. So if we take the second examples, right, so the target values they have given 28, and if we add these values we will not get 28. So in that case they have returned false. Okay, so how we will be achieving it? These approach, first what we will do is, for this, like a simplest solutions will be a traverse over the whole tree, right? Traverse over whole tree and consider every possible pair of node to determine if they can form the requirement sum k. Okay, so for each nodes we have to determine, but we can improve the process if we took a little catch here. So what we will be doing, so the sum of two element, right, sum of two element, let's say it's a z and y. If we add those two element, if it is equals to k, and we already know like x exists in the given tree, right? So if we add two values, we have to compare with the target values, and the target values matches with the those two values, simply we have to return true. And we only need to check if element y, right, element y exists in the given tree, such that how we will be checking. So we have to take these values 5, and we know the target values, right? So what we will be doing it, we will subtract the target values. So the values, now it came 4 after subtracting 9 minus 4, 9 minus 5, we got 4. So we have to check this target value, this difference values in each and every node. If we found that values, so first we will start from the right, from the left side, then we will start it from the right side. So we are checking the next node values. It's a 3, it's not matches with the 4, no. Again we'll go to the next element, it's not matches with the 4. Again we'll go to this element, and we found 4, and simply we return true. Okay, and based on the simple case, right, so we can traverse the tree in both the direction, so left and right child at every step. So we keep a track of element which have been found so far during the tree traverse by putting them into a set. So how, if we didn't find, right, so simply we will add these values 3 in the set. In the first case, right, when we are checking these values, and 9 minus 5, 4, we didn't find it, simply we'll add it in the set, and then we'll move to the next element. If it is not matches with the this difference values, simply we'll add 2 as well in the set. So likewise we'll add all the values where we found the values, the difference values, simply we return true. So for every current node with a values of the values which we have it, we check k minus z, or k minus y, sorry. For every current node with the values of p, we check k minus p already exist in the array. If so, so we can conclude that the sum k can be found by using the 2 element given tree. Otherwise we put the values p into the set. Okay, so if even after the whole tree traverse, right, so no such element p can be found, then some k cannot be found by using the 2 element. Okay, it's a simple approach, right? So what we are doing it, we'll take this root element values, and we'll have written all the algorithm like how we will be doing it, so you can read it. I already read the problem, so let's directly jump into the solutions, what we have done in the solution. Okay, so what are we doing in the solutions? As I said, like I will create one set. So I have created set because in the set internally it manages unique values. So that's the reason, like I use the set, and we have one contain method, so that can search the existing element in the set. And I have created one find methods which accepts tree nodes which has values left and right node. Okay, and then I will pass the target values, which is k, and then I pass the set values. In the first condition, so I'm checking if root is null, simply I have to return false. There is no need to check the complete root because it's already null. And the second condition, as I said, like I will be subtracting the target values, the current root values. So k is a target values, and I'm subtracting from a root dot values. If it is already there, right, let's take an example, it's a 5, then my target k values was 9. So what I was checking it, first I will take the values 5, I got the values, and k minus, so 9 minus 5, which is 4. So first it will check if it is already there. Initial time the set is null, so it's not there, simply it will add that values, and then again it will pass the left values, this one, this node 2, and again we'll check if it is not there, simply it will add 2 as well in the set. So first it adds 5, then 2, then if again it will come and check if it is already there, yes. After subtracting, if it is the matches that values, yes, it matches the values because we need 4, it matches the values, simply it will return the value, it will return the true and false. Okay, let's jump into the lead code. I already wrote the program, so I don't want to waste your time. So what are we doing it? We have a find target method which they have given it. We are passing tree nodes, and we are passing a target value. So what I did is I created one set, and then I'm calling one find method which I have created it, which will give true and false. So 3 values expected. The first is the root tree nodes, then target values, and set. And the first conditions I'm checking if root is null, simply I have written true false. And then I will check the set contains k minus root dot values, then simply is true, otherwise I will keep adding all those values in the existing set. And first I will iterate left node, and then I will iterate the right node. So if we didn't find left and right nodes, it's simply we have to return false. Okay, it's a simple and straightforward solution. Okay, let me run this program and we'll see. Okay, so we have passes 5, 3, 6, 2, 4, null, and 7. So as you see in the diagram, the same input we have given, and the target values was given 9. and we got true. So let's take the second input. We'll see if it is there. Okay, let me run this one. Okay, so this is given false because there is no two node values matches with the 28. So simply we are returning false. Let me submit this one. Okay, it's accepted now. Thanks for today's, and thanks for watching my channel, and please subscribe my channel if you like this video. Please. Thank you guys. Bye bye.